Good morning. This is PyCon Sweden 2021, and we are in the software track. Our third talk today is called Unpack Python Packages, Deep Dive into the Wheels of Python Packaging. And I'm really happy to introduce you to our frequent and famous guest, Alexander Hultnér from Göteborg, Sweden. Alex, good morning. Welcome.
Good morning. Hello. Thank you for having me, and it's nice to be here again. So today I'm going to talk a little bit about Python packages. This talk is going to be a bit different from other talks I usually have because it's going to be a lot more interactive. We're going to actually be building our own packages and also deconstructing existing packages. So should I just get started?
Let me just introduce you quickly. So Alex is a freelancing consultant and speaker from his own company. He's a devoted hacker since early childhood, an avid speaker at many Python conferences and meetings, and an organizer of workshops and courses. Currently, he is making an online course on property-based testing in Python. So please, you can begin. The stage is yours.
Yeah. Hello again. Let's get started with my talk then. So my talk is titled Unpack Python Packages, Deep Dive into the Wheels of Python Packaging. And that's what we're going to do today. But before we start, I'm just going to introduce myself and my company a little bit. So I'm the founder of Hultnér Technologies AB. We also have a product called Papero.io, which is a tool to generate PDF files from standard web technologies. You can use HTML, JavaScript, and Jinja or whatever you want. I'm also a freelance consultant, so if you need help with something or if you just need someone to bounce some ideas with, you can always contact me. I'm also writing a book about Python packaging right now. And there will be a link at the end in the slides to sign up if you want to get more information about the book. All the links are clickable, so everything that's blue is clickable. And you can go to slides.com/Hultnér to find all the slides after the talk. And there will also be a GitHub repository with all the code and all the examples. A little bit about my company then. So Hultnér Technologies is founded by me. Here's a picture of me and Magnus, my partner. And we have an office here in Gothenburg. That's where I'm sitting right now. We do some consulting, also some in-house development like Papero I just told you about. We're also open to hire more people at this moment. So if you're a Python developer, especially in Gothenburg, and are looking for a job or just want to chat, hit me up. You can send an email to contact@hultner.se. So that's that. Let's get started on. So the outline for today is the following. So first, we're gonna see why we care about Python packaging. We're gonna discuss a little bit about what a Python package is, the different packaging distribution types that exists. We're gonna have a hands-on session, which is gonna be the majority of the talk. We're gonna build a package from scratch. We're gonna install it. We're gonna use it. I had to cut a few parts because otherwise this would have become like 3-hour workshop or something. But I'm trying to keep it as brief as possible. Then we're gonna show some modern tooling that makes this very easy. I'm gonna show you some conclusion, and then we're gonna have a Q&A. So why do we care then? Well, one thing is for distribution. So of course, you sometimes want to distribute Python code, maybe a library or maybe a shell tool or a developer tool or something like that. And in that case, reusability is important. So by distributing your code, you enable code sharing, but you also gain some separation of concerns, because you can have one package that does one thing and does it well, and then you can have a larger package that includes this, just like any library you use. Maybe you want to create an open source package, or you want to create one internally at your company, or want to create several. We want to understand the magic behind the curtains, though, so that's why I have this talk. So what's a Python package? It's basically a bundle. So it's a bundle of files, distribution format. There are some different formats. Usually they are either Python libraries or applications aimed towards developers or developer tools, command line applications, stuff like that. Usually they are hosted on PyPI, but they can just as well be hosted on private repositories. I'm going to show a very simple case of that at the end if I have enough time. Formats. So there's a couple of different formats. These are the major ones. So we have source distributions called sdist, usually a tarball. Can be others as well, we'll show you later. Eggs, I will talk about those a little bit, but you can see there's a happy egg here. And we have wheels. So where's the wheel then? Well, it's here. It's the cheese wheel. So because the PyPI is called the cheese shop from the Monty Python skit, the wheels are cheese wheels, actually. So that's just some fun trivia. So what's sdist then? So sdist is a source distribution. So it's usually packaged as a package.tar.gz file, but it can also be a zip, which I think is the default for Windows. You can also use different compression methods with tar, like BC2 or XC. There's a gray one here, C, and that one is deprecated, so I wouldn't recommend that, but I'm just going to include it anyway, so you know it have existed. Never seen it in the wild. As this is basically a bundle of the source code, it needs to be compiled if it's code that needs compilation. It needs to execute the setup.py to understand which dependencies exist. So it's impossible to do some static dependency resolving from them, but it's a good way to distribute the source. And it's good for unsupported platforms, because then you can always build from source. Then let's continue with eggs then. So eggs is an older de facto standard. And eggs is kind of like not used anymore, but I can't have a packaging talk without at least mentioning them. So they were the de facto standard for compiled binaries, but are largely replaced by wheels today. So let's go ahead to wheels. So wheels then. Wheels is the new standard format, and it's a standard PEP. So it's PEP 4.2.7, and it was actually accepted in 2013. So maybe not that new, but quite new. And you can also convert an egg to a wheel. So that's very good. Makes it easy to transition. And it's a version format, so you can improve upon the format, or we can like add some new additions to wheel and create a wheel 1.1 or 2.0 and still have compatibility with the older versions. And one of the great things is that you can resolve all the dependencies statically, so you no longer need to execute code or need to execute a setup.py. Basically, it's an already installed version of the code, which you just have to unpack and copy into the right folders to run. There's also a record that's checked on install, that's signed with all the hashes for all the files. This is more like a building stone to use for signing, not a complete solution, but it's there. And it's yeah, I think that's it. So let's go ahead then. So I don't want to use too much time. So let's go ahead with the hands-on session. So now you should be able to see my terminal. maybe I should zoom a little bit. So let's peek into the wheels then. So I've created this example repository to have something to work with today. Basically, we're going to start with looking at existing wheel. And for that, I've, let's see, that's the wrong one. In my sandbox here, I've added a directory called Flask where I downloaded the Flask library, and this should be somewhat new. I downloaded it quite recently. So here we have the wheel file. So let's start to see if we can understand what it is. So we can see it's a zip archive. So what do we have in the archive then? Let's see. So here are some different files. Obviously, we have the library. We have this dist info folder. So this is where the wheel specific things are. And we can see we have some different files. And let's unzip it then to explore these files. So let's go into the dist info, because the other part is just the library. So the interesting parts for this talk is here. So let's see what we have here then. So we have a record. This is what I talked about. We can see we have some signatures, and we have some number here and some files. We have this wheel file that tells us which wheel version it is. Generator, this is what tool you use to generate the wheel. Root is purelib. There is not something called platlib as well, but basically purelib means that it's a pure Python library, so it's not platform dependent, while a platlib would be platform dependent. So in this case, you don't need to build a new wheel for every platform, and you can see that on the tag as well, because it says py-free none any. So none here is the ABI version, the application binary interface, and any is the platform. So this says that it works with any Python-free implementation. So that's the easiest version, and that's what we're gonna explore today. And that's the usual if you don't have C dependencies. Entry points here, .txt is actually not a part of the wheel format, but it's a part of the packaging documentation for Python, and it's like a way to just show entry points for scripts. So that's good to have. Top level is not really needed. It's a legacy from the egg format, and you don't need it anymore unless you need compatibility with egg tools. It's actually not even mentioned in the wheel specification. Metadata, this probably looks familiar to you. A lot of these things look pretty much like the PyProject.toml or setup.py would look. We have the metadata version 2.1. This is the latest one. 2.2 is in the works, but it's not finished yet, and I don't think there are any super large changes. You can see the name, the version, some summary, homepage. This tool has quite a lot, but some of the more important ones might be the like trove classifiers to see which those are. Requires Python tells us which Python version we can use. And the description content type just tells us about the README, so we can use Markdown as well. We have a reference to the license, and this is the little bit more fun part. We can see it says requires dist. So instead of actually having to execute setup.py to understand the requirements, we can actually see them statically in the metadata. We can see that there are some extra dependencies. We can see some of these things. So let's explore this record then and see if we can understand a little bit more about how that's generated. So let's go into the record. Let's split the screen. So let's just take this main file, main.py. So now I'm gonna navigate up again to the Flask And here we have main.py. So yeah, it's a very simple script, but now we know what's in there. So we see that there it says SHA-256. So let's try SHA-SUM the main. And we can see we get a hex here, so obviously it doesn't match because this is a base64 encoded format. So let's see what happens if we just paste that into base64. Well, obviously that's not the same, it's much longer because this is a hex and we actually want the bytes. So how do we do that then? Well, we have a hex, then we can use some hex tool. Obviously this won't work, so we want to say that it's a plain and we want to reverse the hash. And now we have this, and let's try to base64 encode that. Now we have something that looks, let's see here, bit inc. Yeah, looks like this is the same with the appended equal sign on the end. So where does the 30 come from then? Maybe you can suspect that it's something like, let's check the sizes of all the files here. 30, 2000, okay, yeah, we can see that it's actually the size of the file. So now we know how to generate this. So let's see if we want to just get the SHAs of all the files. Do that from here. Okay, so here we get some SHAs. Okay, so let's do this then. And actually, I've got a one-liner here, which I saved. And here we can see we've almost got what we want. We just got the additional equal sign, and we don't have the size. So let's try a slightly modified version of this. And now we actually have a one-liner in bash to generate the record. Yeah, that makes it quite easy, but of course, a one-liner in bash isn't that readable. I mean, I wrote this, but I can almost not even read it anymore. So what I did was actually to create a small tool, which isn't the most pretty one, but now we have this buildwheel.sh here. Let's close this up. Yep. So here I have explained a little bit more. And of course, there's a warning telling you to not use this bundler for production, but this is actually a complete bundler. In some case, you still need to add like the metadata, but it does all the record and packaging and makes a wheel file named correctly. The name of the wheel file is important because you store some information about the platform support and stuff in that. So basically, we set up some variables. We have a target package, and then we make sure that the directories we need exist. We remove old records and wheel files if those already exist. We do the SHA-SUM as we did before. And then we have a loop here where we read the hex for each file. We print the file name, the second column, and then we print SHA-256 equals, and then we print the hex, but we want the first column, and we want to convert it to bytes, and then base64 encode it, and we want to remove the trailing equal sign and the trailing new line, because we also want to append the size. So for the size, we take the second column, which is file name, we cat it, we count the characters, and we remove the white space and then print it. Then we use sponge. This is because otherwise the record itself would be included in the record, which doesn't work because you can't hash your own file. So the record should be added separately. So sponge would just take all the STD in and then write it to a file when the loop is done instead of streaming it. After that, we zip it up into the wheel file and we're done. So that's quite easy. And let's take a look then here in our sandbox manual package, which I prepared. And I'm looking at the time. I was thinking about rewriting this from scratch. I won't have enough time for that. So let's just take a look here instead. Okay, we don't want to do that. We want to do, let's just do 2 levels. I think that's all we need. Yeah, so these are the files we have here. Here's the old wheel. We can actually remove that. And I removed the wrong file. Luckily, I have Git. So, yeah, okay. So let's try to run this sandbox manual package. And we can see, hello, Alex, welcome to PyCon SE 2021. So let's look at what we did in this package. It's, oh yeah, I can't do that. So what we did is create a hello file, which got the hello function. I just wanted to create a couple of files to actually show that imports and stuff like that works. We have the main file. This is what would be executed if you execute it directly. And we have the init file, which, yeah, is the init file. So when we execute the module, we will see this. But if we import it, we will just get the function. Yeah, so this is our simple hello world package. And now we want to take this and create a wheel of it. So let's do this without any setup.py or anything, just creating the dist info manually and using our build wheel tool to create the record. So let's remove the record for now. And then let's see what I did with the metadata. Edit anyway. So we have the metadata version 2.1, the latest one, name of the package, sandbox manual package, version 0.1, summary here, nothing in this case, my name, my email, required Python version. For this, I'm writing 3.10, but of course this would work in any version. But for now, I have some Trove classifiers. This is really everything I need. I don't need anything more than this. And for the wheel file, in 99% of the time, this will look like identical, because if you create a pure Python library, it will always be purelib. Wheel version is still one. Generator, for fun, I added PyCon SE 2021. Tag, because it's a pure Python package. There's no ABI specifications, and it works for any platform. So that's everything we should need. Let's then do build wheel of this. Wheel built successfully. So now we have a dist folder again. And if we check what's in the file, we can see that we have all the files we wanted. So let's open up a clean environment then. So I have prepared here clean, and let's source this, bin activate, and let's do python sandbox manual package, so we can see that it doesn't exist. Do pip install, and we want to install the wheel. So let's do that. And we can install it, and let's try to run it again. And there we have it. It works. And as an extra, I also created a server catalog. I won't have time to showcase it, but I was going to run a Docker image and install it from our server. But basically, we can see here that we have just a directory named package name normalized, and then we have the file. And everything we need now to be able to install this is actually start a server like this. And now we could do pip install and use this server as a test index. But I don't think we have enough time to do that today. So thank you for looking. Conclusion, source this is for source code. Wheels replaces eggs. Wheels are quite simple zip files. There's a static metadata format, which enables better tooling and faster tooling. We can now distribute binary packages natively without Conda. Packaging is much easier with modern tools. I was actually going to show you a poetry example as well, but I didn't have enough time. But there's some code in the GitHub repository for that. So if you have any further questions, you can ask them. If you want to sign up for my book updates, those are available here. If you want to sign up for the Paper beta, it's here. Here's the GitHub repository with everything you need. And that's it for me then. Thank you.
Thank you, Alex. As Helio says, this is a great tutorial. I totally agree. Thank you very much for sharing with us with this low-level things about packaging system in Python. We have several questions and we have a few minutes left, so let's see. Marcus
I had like 3 times as much content planned, but you know, when you actually stand here and try to do it in 25 minutes. Yeah.
So Marcus is asking, thanks, do you have experience building packages in other languages? Do you think it's generally better or worse in Python?
I have a little bit of experience, and I would say that the packaging ecosystem in Python today is quite good, but the reputation is still bad. Wheel formats is one of the things that have improved it significantly. It actually solves most of the problems that Conda was created to solve. I didn't go into how you handle it for C extensions, but there's something called build wheel CI or something like that, CI build wheel. I don't create C extensions, but then it's a little bit more complex. But if you're working with pure Python libraries, it's very easy. And basically, if you use something like poetry, you can just run poetry build, and it will create a wheel for you and everything you need. So this was more just to show you how it works behind the curtains. It's much, much simpler if you try to build it yourself.
One more thing from Helio. Is it possible to sign your wheel using PGP GPG?
So I think there is like some stuff in the record format where you can also attach a signature for the record. And for that, you can actually add a MIME type. And I think there is built-in support for JVT. And I don't remember if there's built-in support for PGP as well. But the thing is that the record is more created to work as a way to have the basic building blocks, and then you can sign the record with some kind of external tooling, and the MIME type can tell you how that should be handled. Yeah, that would be my answer.
Okay. So another thing again from Abdulrahman. We have to move to another talk. Thank you very much. And we also thank our audience at YouTube. So I hope to see you next year at the same conference. Thank you. Bye.
Thank you.